This question is asking us to create a couple polynomials in factored form, and we need to use these zeros to be able to get that polynomial. Now in part A, we're given zeros of -3, 1, and 4, and we need to come up with factors from those zeros. So to do that, I'm going to just write x equals -3, and we have to set this equal to 0 to get that factor. So I'm going to add 3 here, and that's going to make this right side equal to 0. And to keep that balance, I have to add 3 to the left side as well. So we're going to have x plus 3 equals 0, and this x plus 3 is a factor, and it's a binomial, but that's okay. I'm going to take x equals 1 and x equals 4 and get my factors from there too. So as you can see for this part, I subtracted 1 from both sides. That canceled that out to give me 0. And then I had x minus 1 on the left side. That's going to be my binomial. And then here I subtracted 4 from both sides. That cancels out to give me 0. And I have x minus 4 is my binomial. And these three binomials here are going to be my factors. And I could set them equal to y. And then write them down here. So I have x plus 3, x minus 1, and x minus 4. So this is going to be the polynomial that represents these three zeros, and it's going to be written in factored form. Okay, in part B, we do the same thing, except there's a fraction there, so it's going to make things a little bit more challenging. So I start off by writing out my zeros again, and I want to set each one of these equal to 0. So to start off with this one, I'm going to add 1 to the right side, means I have to add 1 to the left side. And then on the left side I'll have x plus 1. That's going to be my factor, which is a binomial, and it's set equal to 0. Now for the 8, I do the same thing. I took away 8 from both sides. That canceled this out to give me 0, and then I have x minus 8 as a factor. Now the fraction is what's tricky. So I'm going to do this two different ways. One way would just be taking away 2/3, right? If I have 2/3, I could subtract it and it goes away. That means on this left side I have x minus 2/3, which equals 0, and then we're all good, we have our factor. But we don't want our factors to have fractions like this. So the other step that I'm going to have to do is multiply this entire binomial by 3, and that's going to get rid of this 3 in the denominator. So I'll show you what I mean. 3 times x, and then we do 3 times this. So 3 times x is just going to give me a 3x, so we're good there. And then when I do 3 times 2/3, well, 3 over 3 would cancel out, and we're just left with a 2. And then that's going to equal 0. And if you're like, wait, what just happened there? Well, here's another way of thinking about it. 3 times 2 is 6, right? So then we'd have 6 over 3. So 6 divided by 3 is 2. And there's my 2 right there. And that's going to be a factor. Okay, so there's that way to do it. Or, let's do this one more time here. We have x equals 2/3. You could also get rid of this fraction right away by multiplying by 3. So take all this and multiply the entire equation by 3. So now on this left side I have 3x equals, and then 3 times 2, remember that's going to be 6, and then it's divided by 3, so that's going to be 2. And then the whole purpose of messing with this 0 anyways was to set it equal to 0, so now we have to take away that 2 on the right side. So take away that from the left side as well to keep the equation balanced. That goes away, I'm left with 0, which is what we wanted, and we have 3x minus 2, which is our factor. So that's going to be the same factor as what we got over here. Again, two different methods. I don't know what would be easier for you, but either work. Then the last step, we're going to set everything equal to y. So y will equal the first factor, which was x plus 1, the second factor, which was 3x minus 2, and then the third factor, which was x minus 8. And there's our polynomial that consider all three of these zeros.